Welcome to the SimForm tutorial on creating custom materials. In SimForm, you can choose the material from a list that contains widely used materials for mold cooling applications, or define a new material that helps you meet the specific needs of any plastic molding project. The new custom materials you create in one job is added to the material list and becomes available for use in all your projects. You won't have to define the same material every time you need it, which saves time. Your custom materials are private and only accessible to you, ensuring that your work is confidential. In this video, I will show you how to create custom materials for both mold groups and plastic parts. I will also show how to compare the safe ejection time for the same mold design using different mold materials to evaluate their thermal efficiency and choose the most suitable material for your project. For this example, I will use a mold design of an all-terrain vehicle grille model. The mold, plastic part components, and the cooling system are already defined. Now let's start by creating a custom material for Mold Group 1. To do that, in the Mold Group 1 panel, I will expand the Select Material list and click Add Material. In the Custom Mold Material window, I will define the thermal properties of the new material. It is important to use the predefined units specified in SimForm to accurately define the properties of your new material. For this example, I will create a mold group material for 420 stainless steel. So I will type the material name and enter its density, which is 7,833 kilograms per cubic meter. For its thermal conductivity, I will use a value of 29.1 watts per meter Celsius, and for the specific heat, I will use 460 joules per kilogram Celsius. SimForm uses these material properties to calculate the heat flow through the mold components to the cooling channels. I'll use the same material for Mold Group 2. Now I will create a custom material for the plastic part, for example, polyphenylene oxide. So in the plastic part panel, I will expand the Select Material list and click Add Material. In the Custom Part Material window, I will enter the material name and the following parameters: a density of 1,100 kilograms per cubic meter, a thermal conductivity of 0.2 watts per meter Celsius, and a specific heat of 1,300 joules per kilogram Celsius. I will set the plastic injection temperature to 100 degrees Celsius and the ejection temperature at which the molten plastic solidifies to 60 degrees Celsius. The mold temperature is the temperature of the mold cavity. It can vary depending on the material and the process. For this example, I will use 30 degrees Celsius. SimForm uses the plastic physical properties to calculate the heat flow from the plastic part through the mold components. After defining the mold and plastic part materials, I will click Submit Job to solve the model. While the simulation is running, I will create a second job and select a different material for the mold components from the predefined material list, such as steel 4140. Then I will submit the second job. The simulation results show that the cooling time for the 420 stainless steel mold is 23% higher than that of the steel 4140 mold. However, the temperature distribution in the plastic part is similar for both materials. This implies that using the 4140 steel mold could result in a shorter overall cycle time without significantly impacting the quality of the final product. Selecting the right material is critical for the success of the molten plastic molding process, where material properties play a key role in determining the quality and efficiency of the final product. You can use SimForm to conduct multiple simulations to evaluate the thermal efficiency of various mold and plastic materials. It lets you make a stronger business case for investing in higher-priced or faster-wearing materials, which can optimize the mold cooling process. This leads to improved product quality, shorter cycle times, and ultimately cost savings.